Today we're going to review what we did a lot of in the last unit is choosing a model review. And we looked at three types of models when we were looking at two variable statistics or two pieces of data, X and Y. The three most common models that we've looked at so far this year are, the first one is the linear model, and its general form of a linear model is y equals mx plus b. And we did these all on the calculator as well, and we're gonna review that on the calculator today too. The second one, and we spent a unit on this, and I believe this was unit 5, was the exponential model, and its general form is y equals a times b to the x, where a was our initial value and b was our growth factor. In the linear model, our starting value was the y-intercept or b, and our rate of change was the slope. The third type of model after linear and exponential, and this was unit 6, was the quadratic model. In its general form, this was everybody's favorite unit, was y equals ax squared plus bx plus c. And if you remember what each of these models looked like, a linear model clearly was a straight line, exponential model was a curve, and the quadratic model was a parabola. Okay, so in this section down here, this section right in here, these are just the directions on how to put all of this information in the calculator. How to enter a list, how to turn on the stat plot, how to turn diagnostics on, how to look at your graph, so forth and so on. We've done that over and over again, so I'm not going to put any calculator directions on here. But I did take this data down here, and I used my favorite graphing calculator to put that in the graphing, or to put that in the calculator. I used Desmos, so we could see what that model looks like. So let me show you that. Okay, so here is the screenshot I did of Desmos. I took this table right down here, and I plugged it into Desmos. You're going to plug it into the TI 84, and the directions are what I boxed up there in yellow. And looking at this, you can clearly see, here's our graph right here. This looks like it's going to be an exponential model, but we need to have a little more proof than what it just looks like. So let me get that out of the way and put that up there. So we're going to use our calculator. You're going to use your calculator to find the linear model, the exponential model, and the quadratic model for each. And hopefully, by finding the r squared value, we can prove, mathematically, that an exponential model is the best fit for this. So go ahead, use your calculator, and find the linear, exponential, and quadratic model for each of those. Okay, so here are each of the models for that set of data. Here's our linear model, y equals negative 4.57x plus 11.17. That has an r value of 0.808. Here's our exponential model. Look at that, has an r value of 1 and pretty much matches this picture up here. And our quadratic model has an r squared value of 0.985. And again, we're using the r squared value because the quadratic model does not give us an r value. So to make everything comparable, we use the r squared value for each. And here's the equation for that, for the quadratic model. So it's clear, you can see from our r values, that the model of best fit for this particular set of data is exponential. And at this point, you should know how to find all of these on your calculator. And again, the stuff that I boxed up in here in red are all the directions for that on your calculator. Okay, so let's take a look at example 2. The table below shows the number of people participating in high school athletics since the year 1970. So this is 1 year since 1970, 2 years since 1970, 20 years, so forth and so on. So we're going to find the line of best fit. And again, using your calculator, Years since 1970 goes in list 1. Number of athletes goes in list 2. And we're looking for the exponent or the linear regression. So when you go to stat and calc, you make sure that you're arrowing down to number 4 to find the slope in the y-intercept. And when we do all that, hopefully you're pausing the video and doing that, our linear model, because it says the line of best fit, is 87,390.5x plus 4,018,431.4. So the next is to interpret the real world meaning of the rate of change. And remember, another word for rate of change is slope. Interpret the real world meaning of the rate of change and slope. So what does this slope tell us about the increase, because it's positive, of the number of athletes since 1970? And what does this number right here tell us about the number of athletes in 1970? So the rate of change, well, the rate of change and the slope are the same. So after 1970, there is an increase of 87,390 people participating in athletics each year. So we're going to use this equation to make predictions, and that's what this whole unit is about, making predictions. So we're going to predict the number of participants in 1988 and state your answer as a complete sentence. Well, first we have to figure out, okay, well, how many years has it been from 1970 to 1988? So we're going to let x, in this case, equal 1988 minus 1970, and that's a difference of 18 years. So when we plug 18 into our equation up here, we get 5,591,460 people. So, and it says to state your answer in a complete sentence. In 1988, 591,460 people participated in high school athletics. Okay, letter D, predict the number of athletes in 2014. State your answer in a complete sentence. So again, our X, our predicted, the years we're predicting is the years after 1970. So in our equation, X is equal to 2014 minus 1970, which is a difference of 44 years. So you can plug it in, or you can use your table of values, but using a complete sentence, in 2014, and we should say approximately, because we're using this to make a prediction, approximately 7,863,613 people participated in high school athletics. Participated, sorry. in high school athletics. Okay, so this was a quick one for today. So now on to the video questions. Slope was, okay, multiple choice number 1, given the following data set, what is the model of best fit? So you're going to use your calculator, determine if it's going to be a linear model, an exponential model, or a quadratic model. And again, remember, this is your L1 and this is your L2. Number 2, using your model of best fit, find the number of young adults predicted to audition in 2008. How does this compare to the actual number of auditions below? So using this data right here, the year and the auditions, you need to find your model of best fit, whether it's linear, quadratic, or exponential. But be careful when you're putting your years in here. You want to put the years. You're going to let x equal, marker's not working, the number of years since 2004. So for 2004, you'll enter in 0. For 2005, you'll enter in 1. Then 2 years since 2004, 3. This would be 4, and this 5, and then 6. And then your y values will be right here. So whatever model you're choosing, your x value is going to be 4, because the difference between 2008 and 2004 is 4 years. Okay, so make sure you put your answers in the Google form.